So if you recall that, yeah, see now the circuit diagram I have drawn here. Okay, here the supply voltage is Vs, and you have four thyristors, 1, 2, 3, 4. Okay, so that makes a full converter, single phase full converter, and that is going to the series motor to the resistance, just like how I have shown in the previous class. Okay, for the semi converter, the same kind of resistance I have shown here. Okay, then we will go for the analysis. Okay, so now, so once again, that two types of conductions are there: continuous conduction and discontinuous conduction. First, we will go for the continuous conduction mode. So in the continuous conduction mode, so we will see how we'll draw the waveforms. Okay, we'll draw the waveforms of same procedure, just like how we did in the last class. So first we'll draw the supply voltage. Supply voltage waveform we draw. Okay. So this pi, pi. So it's a sinusoidal voltage. Okay, so it is Vs supply voltage. Okay, whereas it is omega t. Okay, now we will draw the output voltage Va. Va is the output voltage of the converter. Okay. So voltage of the converter. So you see here is pi. This is 2 pi. Then you have a firing angle alpha, just like the case of the previous topics. So you have alpha, and then here you have pi plus alpha. Let me take this as pi plus alpha. So this is pi plus alpha. So now you see now. So I have taken continuous conduction. So I hope you know the continuous conduction means that the current in the armature is never zero. It is always there. Okay. So when it is always there, if you look at the circuit diagram, you will understand only one thing. That is that if the current has to be continuous, that is IA, either 1,3 or 2,4 will have to conduct. So at any instant of time, either 1,3 or 2,4 thyristors will conduct. That's the continuous conduction. Okay. So at omega t is equal to alpha, at omega t is equal to alpha, will trigger, at omega t is equal to alpha, we will trigger the thyristors 1 and 3. At omega t is equal to alpha, will trigger thyristors 1 and 3. So 1, so 1 3 will conduct. Then what you find out is that if 1 3 are conducting, then the direction of the current is like this. Okay, this is the direction of the current. Then it will enter into the motor. Okay, that's it. This forms a closed path. Through the source, it forms a closed path. So I will write here that when alpha less than equal to omega t less than equal to, okay, we will see the value later. So what is the answer? You will find out is that Va is equal to Vs. Why it is so? Because just like the previous case also, that the output voltage is same as the supply voltage if the thyristors are conducting. So Va is equal to Vs. So if Va is equal to Vs, what do you find out here is that So here at alpha VA is equal to VS. So you draw the waveform similar to that. Okay. So now this is till alpha, till omega t is equal to pi. After pi, the supply voltage becomes negative. So even though the supply voltage becomes negative, the thyristor 1 and 3 will not be turned off because due to the nature of the inductor here present in the motor. So and that too we have taken it as a continuous conduction. So the current in the inductor will still be there. So it forces the thyristors 1 and 3 will conduct further time. So you will find out that. So 1 and 3 will conduct and it will conduct till you fire the second set of thyristors, that is 2 and 4. So till you fire thyristors 2 and 4, that is at pi plus alpha, thyristors 1 and 3 will continue conducting. So if thyristor 1 and 3 will continue conducting, that is till pi plus alpha, VA is equal to VS. So you must understand this thing that VA is equal to VS. Okay. So we will see now VA is equal to VS in the sense, so this will go further here like this. Okay. So this is VA is equal to VS. Then at pi plus alpha, what you are going to do is that at pi plus alpha, you trigger thyristors 2 and 4. You trigger thyristors 2 and 4. So when you trigger thyristor 2 and 4, then the direction of the current will be like this. Okay. Then once again, you see same direction they are flowing. Okay. So in that case, what you find out is that once again from pi plus alpha less than equal to omega t less than equal to 2 pi plus alpha, I will take directly. So in this case, what you find out is that VA is equal to minus VS. VA is equal to minus VS. So you will find out this thing that the output voltage will be something like this. Okay. So this you will find out here. Okay. So now you see here, once you understand the supply voltage, output voltage waveform, this is how you get. Then what you need to know here is further is that what is the current waveform? The current waveform you will get here. Okay. Simple thing. So the current waveform IA here is a continuous conduction. So you will find out this thing that as it is a continuous conduction. Okay. So something like this you will find out. Yeah. You will find out like this. Okay. So we'll go ahead with this. So with this thing, so now we will derive the expression for the supply output voltage. We'll derive the expression for the output voltage. Okay. So now you see what is expression for the output voltage. You will find out here is that VA is equal to VA the average value. So average value is equal to 1 by time period. Here the time period is pi. Yeah, integration alpha to pi plus alpha I will write. Okay, it's better I will write alpha to pi plus alpha. So alpha to pi plus alpha. In this duration, VA is equal to VS. What is VS? VS is VM sin omega t because sinusoidal waveform. So d of omega t. So then what you find out is that do the derivation of this already we did in the previous cases of the separated DC motor. So we got this answer to Vm by pi into cos alpha. You can do that, you will get the same answer here. Okay, this is what we got the average output voltage. Now as in case of the motor, we know one more equation for the VA, that is EB plus IARA. So what is EB in case of the G series motor? You please recall, then you'll find out. this equation. So this is EV plus IARA. So IARA. So that is equal to 2 Vm by pi into cos alpha. This is what we got. We can simplify this further. Okay, how can we simplify this further is that you recall the torque equation. If you recall the torque equation, so we got some torque equation previous class also. Okay, so we will use the torque equation there. Okay, so just recall the torque equation because we want to know the relationship between speed and torque. So torque equation is equal some constant K3 into Ia square. This is the torque equation we got last class also. Just recall that yourself. There is nothing wrong in this. Then if you go through the previous class notes, you will understand yourself that it is some constant into Ia square. So from this, what is Ia? What is Ia is that Ia is equal to square root of P by K3. Okay. So we will use this at an appropriate time. So first of all, we will find out what is N from this. N is equal to cos alpha minus IARA. But what is IA? Square root of P by K3 into RA whole divided by K2 plus K1 IA. Once again, IA is equal to T by square root of T by K3. Okay, this is the relationship between speed and torque. Okay, so that we are going to draw as a graph. With the speed, this is the speed, this is the torque. Okay. So what you find out is that we start with t is equal to 0. Then if it is t is equal to this part is 0, this part is 0. Then only alpha is available. So let me take alpha is equal to 0. If I take alpha is equal to 0, then it's the maximum value. So somewhere you will find out here. Then after that, you try to decrease, increase the value of t. So if you try to increase the value of t, what you find out is that you find out something like this. Okay, we'll check that. So we'll see here. We substitute. Yeah, this is what we got here. Okay, so when you put the torque 0, so put the torque 0. For example, if you put the speed 0, then in that case, okay. So we'll see now. As per the equation only, we'll see here. Then you'll find out some value here. Then after that, you try to increase the value of t. Then the numerator will decrease, whereas the denominator will increase. So it will increase further. So the decrement is it will decrease further. So the decrement is not a linear; it's a non-linear. So we'll find out something like this. Now, so this is alpha is equal to 0. Now you try to increase the value of alpha. So when you increase the value of alpha, what do you find out here is that the cos value will decrease. So we'll find out this. Okay, so we'll find out here. This alpha is equal to 30. Alpha is equal So likewise, this is there is nothing serious here. That only thing is that you must substitute the value of t for different value of so substitute value of t for different value of n. Okay, then we can easily get these equations. Okay, we can easily get these equations here. Okay, so this is what we got now from the equation. From the equation of this, we got this is the so from the expression of the torque and equation, you just check yourself. Anywhere we went wrong, you check. Otherwise, we'll go ahead with this. So we'll go ahead with this. Okay. So this is what we got. This is what we got. Okay. Then we'll go for the discontinuous conduction. Okay. Then we'll go for the discontinuous conduction. So what is the case of discontinuous conduction is that I hope you know the discontinuous conduction. So discontinuous conduction, a part of the current it will become zero. So do one thing, I'll just copy. I'll bring this here. Okay, so I'll just make this something. So this is Vs. So discontinuous conduction, what do you find out is that so at pi plus alpha, sorry at omega t is equal to alpha, you will find out that so I'm going to draw the output voltage waveform. Voltage we'll see now. Yeah. So this is discontinuous conduction mode. Discontinuous conduction mode. This is omega t, whereas this is Va. So first what you do is that pi plus alpha 1 and 3 will conduct. So when 1 and 3 are conducting, then that I have shown you there here. Okay. So I will add something like this here, alpha. So alpha less than equal to omega t less than equal to, okay, some value is there. So in that case, Va is equal to Vs. So I will draw that waveform here. Va is equal to Vs. Then so at omega t is equal to pi, you will find out the supply voltage is negative, but still there is some energy present in the motor in the inductor. So that energy will force 1 and 3 will to conduct to further time. So then in that case, Va is equal to Vs. So it will continue further. But what we have to find out is that this energy will be over at some angle beta. So this is beta. So at beta it will be over. So when it is over, then what do you find out is that what exactly you'll find out is that 1 and 3 will stop conducting, then Ia will become 0. So when Ia becomes 0, then the Va value is equal to Eb, just like how we have seen last class also. Okay. So Eb in the sense, then it will go like this. This is Eb. Okay. Then at pi plus alpha, okay, So what do you find out at pi plus alpha is that at pi plus, so this will be EB. So till, so I will write here it is till beta. Now from beta less than equal to omega t less than equal to pi plus alpha, what do you find out? VA is equal to EB. Then after that, that is from pi plus alpha onwards, what do you find out is that you trigger theresa number 214. So when you trigger theresa number 214, once again, what do you find out is that VA is equal minus Vs, just like the previous case. So you will find out it will go up, then so same procedure it will follow. Okay, so this blue color will be there. Yeah, this kind of waveform you will find out here. So this will happen till another range. So in this range, I must tell you this thing that, so you can say, so pi plus alpha to, yeah, some 2 pi plus some angle. So that angle, so that that duration is same as this duration. So the duration is beta minus alpha. So beta minus alpha in the sense, it will be 2 pi plus some value here I will write. So that value will be approximately, now duration is same as this duration. So that way you have to find out. Okay, so somewhere it will go 2 pi plus some value. So that value is how much in the sense, beta minus pi. So yes, beta minus pi. So it is beta minus pi. Then it is pi plus. So yes, so likewise you can say it is beta minus pi. So with this, you can easily get the durations properly. Okay, so then we'll go and draw. We'll go and draw the current waveform IA. Okay, so in this case, what do you find out is that for this small duration, that is from beta to pi plus alpha, the current is zero. So I will say this thing that the current starts from here, it will end there. Okay. Yeah, this is the output current waveform. Okay, this is output current waveform. Okay. And then what we are going to do is that, what is the output voltage expression? VA average. Okay. And what is the current expression? IA of omega t. Okay, these two expressions, okay, the expressions for these two, okay, like I told you in case of your uh, uh, in case of your semiconductor also, you have to find out this, and the answers for this already you know. Okay, the answers for this are same as the answers you got in case of single phase full converter fed separate lecturer DC motor. There is no other change you will find out for the expressions of V average and IA average. Okay, so because these values, what is the difference you will find out between the separate lecturer motor and DC series motor when you go through when you compare with a circuit diagram. In terms of a circuit diagram, if you compare, what do you find out? Only one difference you will find out. What is the difference is that in place of RA you have RA plus RF, that's it. So you have to do that. Wherever you get RA, you substitute, you replace RA with RA plus RF, then you will get the expressions that you got already. Okay, so that I'm not going to do here because that we did in the last class itself. Okay, so now, so now with this, all these derivations are over. So now what I'm going to do is now is that we will like to solve a numerical problem now. Okay, in for the case of the series motor, we'll solve a numerical problem. Okay, So let me go with this. See the speed of a 20 horsepower to 10 volt 1000 rpm DC series motor is controlled by a single phase full converter. The combined field and armature circuit resistance is the combined armature circuit resistance, that is Ra plus Rf, he's saying 0.25 ohm. Okay. K1 is equal to, he has given Newton. Okay. K1 value he has given 0.03 Newton meter by ampere square. Okay. So then K2 he has given K2 is equal to 0.075 volt second per radian. Okay, this is K2 he has given. Okay, and then what we need to understand here is that the supply voltage is 230 volts. Supply voltage is 230 volts. Okay, assuming continuous and ripple free motor current. Ripple free motor current. Motor current. Determine the following. Determine the following for firing angle 30 degrees and speed n is equal to 1000 rpm. Now what you have to find out is that one, the motor current, two, the motor torque, three, the supply power factor. Okay, so now this is the question. So he said it is a DC series motor. So always remember that to solve the problem, first you see what he's asking. He's asking motor current. Okay, he's asking motor current, motor torque. Okay, then the supply power factor. Okay, so we'll follow the same procedure. Okay, so first of all, where can I find out the motor current? First of all, IA. So we need some equation for IA. So we generally get the equation for IA. I will write here the equation for IA somewhere we got in case of the motor. Solution now you see here how we get VA is equal to EB plus IA RA. This is one equation in which we will find out IA. Okay. Then we'll do one thing. Okay. So EB plus IA RA. This is one equation in which there is IA is there. So we'll recall what is EB. So if you recall EB, then in case of DC series motor, please recall one thing we find out what is that K1 IAN K1 IAN plus K2 N. This is one thing we got. Now, see here you got K1, K2, here also you got K1, K2. But one thing you must understand before, without any confusion, that whether the both K1, K2s are same or there is a difference. So how to find out that is that it's the good practice to find out to just check the unit here. What is the unit here? Is the unit here is volt second by K2. Now you see the K2 here. What is K2 into N? K2 into N is the voltage. So K2 into N is the voltage. So as this is voltage, is it voltage? So voltage is equal to K2 into N. Then what is the unit of K2? Unit of K2 is voltage by speed. So voltage by speed in the sense speed in RPM. So it is volt per RPM. So this is K2. But here what is the unit here? Volt per radian per second. It means it is. So he's asking. The K2 which he has given is not the K2 here. It is different K2. Why is this different K2? Is that here the unit of the K2 here is voltage per RPM, whereas here the unit of the K2 is voltage per radian per second. So it means you have to convert the RPM into radian per second. So how do you convert that into radian per second? Is that you see now? So you have two EMFs, one by one EMF we are finding out here. So how to find out that is so EB2 I will take it as this is EB2 because this is EB2 and it is EB1. This we already discussed. So EB2 is equal to some constant K2 into N. So I will write K2 into N. I can write it as 2 pi N by 60. So 60 omega by 2 pi. So now this whole thing. Now in the question he has given this whole thing. So this whole thing he has given because it is now omega. So voltage by omega. So voltage by radian per second. So this K2 into 60 by 2 pi, this value he has given in the problem as 0.075. That's important. This is how we find out the constant values because it depends on the unit. You should not take directly. If you take directly, then you may get confused. So always see the units are same or not. If the units are not same, then you have to convert. So this K2 into 60 by 2 pi he has given that as 0.075. Okay. Next, what he has given now? 0.03 into Newton. So K1 he has given as Newton meter by ampere square. But you check yourself. Is this K1 has the same unit? No, because it is voltage per ampere into RPM. So there is different constant he has given. So that constant we will find out now. So to find out this constant, I think it is his in terms of Newton meter per ampere square. So it means you have to check the torque equation. So what is the torque equation he has given? You have to check. So what is the torque equation he has given is that. So I will write one thing here that torque equation, if you recall, torque is equal to EB into IA by omega. This is torque. So then we'll do one thing that is equal to EB. How can I write EB is that? Yeah, I can write EB as K1 IAN. Let me write K1 IAN. K1 IAN. K1 IAN. Okay. Plus K2N. Okay. Plus K2N multiply with IA divided by omega. So we observed one important thing. I will just recall that torque is equal to K1 IA square into N plus whole divided by omega into K2 N into IA by omega. So Last class, last class we have seen one important thing. What is that thing is that we have neglected this part. Which part? This part we have neglected. This part we have neglected because this is because of the residual magnetism. So we consider this as very small. So then we neglected that. So as we neglected that, there is only one part is left. That is, what is the part is left now? The first part is left, that is T is equal K1 Ia square into N by omega. Then we'll simplify this further. So how we simplify this further is that K1 Ia square into N. I will write this as 2 pi N into 60. Then N will get cancelled. Then K1 60 K1, that is in the numerator, divided by 2 pi, that is in the denominator. So into Ia square. Now you see yourself now. What is the unit of this one? What is the unit of this one? Because one side it is torque, other side it is Ia square. So it is unit of this is torque by current square. So it means Newton meter per ampere square. So this value he has given in the problem. So this is how you proceed always. This is how you proceed always. Okay, 60 k1 by 2 pi. So this value he has given in the problem as 0.03. Let me write that 0.03. So that's important. So in the problem, what he has given is that K2. So now please see he is now here. Okay. So this is the constant he has given. So this is how we find out what is the constant he has given actually. So 60k1 by 2 pi, that is 0.03. So that is the constant he has given. Another constant is 60k2 by 2 pi. So better I will write this side here, that what is the constants we got at the end. Is that 60k2 by 2 pi, this value he has given as 0.075. Another constant 60k1 by 2 pi, that is 0.03. These are the two constants he has given. So now we will use this equation once again. So to use this equation, I told you already that we need this equation here. We'll bring this equation here. Okay, we'll bring this equation here. So EB is equal to K1 IA N plus K2 N. Okay. Yeah, please see now. Yeah, sorry for the interruption continuously. Okay. So now you see yourself. Now this K1 IA is there. Okay. So K1 IA, you just see this now. What you need to understand here is that is equal to, I can write N as 2 pi N by 60. I can write. So N as 2, so N is equal to, sorry, omega is equal to 2 pi N by 60. So if it is 2 pi N by 60, then I can write N as 60. So 2 pi n by 60 is equal to n. So 60 omega by 2 pi. So I will write here K1 K1 K1. So 60. So 60 it will come this side 60 by 2 pi into Ia into omega. I hope you understand because 2 pi n by 60. So plus this also I can write it as 60 K2 by 2 pi into omega. So this I have written like this. EB I have written like this. So EB I have written in terms of this. Now what you must understand is that this value we know. This value we know. This value also we know. So that we will substitute now. EB is equal. So EB is equal. So this value is how much? We got the answer. This value already we got from the data, that is 0.03 into Ia omega plus this 60K2, that is 0.075 into omega. So these are the, this is EB value. Then what is VA value? Because VA is equal to EB plus IA RA. So that is equal to EB is equal to 0.03 Ia omega plus 0.075 omega plus Ia RA. So from this we can find out what is Ia. So Ia can be written as, so VA minus 0.075 omega whole divided by, so 0.0 whole divided by 0.03 omega plus RA. So this is Ia. Now first question is that you have to find out the motor current. So as you need to find out the motor current, you see here, as we need to find out the motor current. Now we got the equation for the motor current. So once we got the equation for the motor current, what are the unknowns in this motor current? So there are several unknowns are there. So unknowns are there. First thing is that omega. What is omega now? Omega you can easily find out. How we can easily find out is that omega is equal to 2 pi n by 60. So n in the problem he has given us 1000. So 2 pi into 1000 by 60. So what you will get omega? Yeah, I will do this in the calculator here. So 2 pi into 1000 divided by P. So we got 104.72. So omega 104.72 radians per second. So we got omega. What are the unknowns? Other unknowns? Yeah, omega. So RA is there. So RA in the problem. Please see here, RA here is nothing but, what you must understand is that here I told you already that in case of series motor, wherever you find out RA, you will have RA plus RF. Let me just modify this. This is the case of the series motor. So wherever you find out RA, you replace RA with RA plus RF. So RA plus RF. So RA plus RF value he has given. RA plus RF value he has given, that value is how much? 0.25. This also he has given the data. Now what is the other unknown? Now VA is the other unknown. So what is VA now? What is VA? So to find out VA, so what we are going to do is that, to find out VA, okay, so now VA is the output voltage of the converter. So this is fed from a single phase full converter. So this is fed from a single phase full converter. So what is the VA for the full converter? And he has given one important thing, that is a continuous conduction. It's a continuous conduction and ripple free motor current. So it means just like the previous cases, IA is continuous, and also it's a constant value. IA is just a constant value because this is a ripple free motor current. So we got this sentence several times even in the previous problems also. I hope we can understand this now by this time. So it's a continuous, and so you have to take the continuous conduction. So in the continuous conduction, what is the VA expression in the continuous conduction? If you recall, then it is 2Vm by pi into cos alpha. It's a direct formula we got already. We derived this. So 2 into 230 into root 2 divided by pi into cos. So what is the value of alpha he has given in the problem? Let's see, he has given the problem as 30 degrees. So you put cos 30. So that's it. So then you will find out the value of VA. So now what is the value of VA? We'll just go through here now. Okay. So this is cos 30 multiply with around 4 multiply with 230 multiply with 2 divided by pi 179. So we got the answer 179.3 volts. Now we got everything to find out what is IA. We got everything to find out IA. So IA is equal to now 179.3 minus 0.075 into omega. Omega value is how much? 104.72 whole divided by, now everything we got now, 0.03 into 104.72 plus 0.25. We got everything. So if we simplify this, okay, we have to simplify this, then only we'll get the value of IA. So it is 7. So 179.3, 171.45, 171.45, so 0.03. So we got 50.55. So this is your armature current. So we got the first answer. First question, we solve the first question now. So first question is over. The motor current we have. Now next is the motor torque. Please recall the motor torque. So second question is motor torque. See, just now we got an expression for the motor torque somewhere. Somewhere we got the motor torque. Yeah, this one. T is equal to 60 K1 by 2 pi into Ia square. Already we know what is K1 by 60 K1, but that is 0.03. So we'll write directly here. T is equal to 0.03 into Ia square. So, 0.03 into 50.55 square. We'll get the torque. So 76.66. So 76.66 Newton meter. So this is the torque. What is the next question? It is left now is that, yeah, supply power factor. Now this we have been solving this part, supply power factor, several times, and I told you already this thing that supply power factor, you cannot use this formula cos theta, because that's only for the sinusoidal excitation. For non-sinusoidal waveform, that formula you cannot use directly. You have to use this formula. What is that formula? Real power divided by apparent power. So real power is always this, I told you several times. Okay, so you got because if you recall, real power in the sense, what is the output power? So real power is the output power of the converter. So output voltage is VA, output current is IA. Okay, so divided by the apparent power is Vs into Is. So both are RMS. So this one is a DC. VA is DC. IA is also DC. So these are DC values, whereas these are RMS values. So this is already we have done this. Okay, so I don't need to give the explanation here. So in that case, what do you find out is that what is VA? We got VA armature voltage somewhere we got just now. See here, armature voltage VA. Yeah, we got 179.3. This one is 179.3. So 179.3 into IA value also just now we got 50.55 divided by Vs, that is RMS value is 230 volt supply voltage. Now what is the RMS value of the supply current? So this is the question. It is left now. So to understand this RMS value of the supply current, okay. So just recall one important in case of the similar kind of problem we have solved, okay. Then what we did is there in those cases we got IA function like this for ripple free current, for ripple free current and continuous and ripple free current we got the IA value something like this. This we got and its height is IA. This is IS function. See this graph we already got in the previous problems itself. Similar kind of situations we got these problems. We got this waveform IA. So for this the RMS value also I told you the RMS value here is same as the peak value, that is IA itself. So RMS value here is IA itself. This already we have find out. So RMS value of IS is IA itself. So that I will write here IA. So what is IA here? 50.55. Then this 50.55 will get cancelled. Then it is 179.3 divided by 230. So we'll do this 179.3 divided by 230. So 0.779. So it is 0.779 lagging because this is the lagging power factor. So that's it. So this is the solution for this problem.